Right, circle theorems. There's about 5 that you need to know for intermediate tier. They're really straightforward and simple, okay, and a lot of common sense really. Let's look at the first one here. So it says angle in a semicircle is a right angle, okay. So if we look here, right, because we have this line here AB, right, that line AB is a diagonal, isn't it? It's a diagonal of the circle because it's going through the center O, right? And as a result then, you have split the circle up into 2 halves, okay? So you've got one half here, you've got the other half here, right? So that's why we call it angle in a semicircle. And the angle formed is going to be a right angle, okay? So whenever you come from the ends of the diameter, the end there A, the end there B, the line coming from each of those points, when it hits the circle, will always be a right angle, okay? Obviously, the shape there is a triangle as well, okay? But I can try any other point. I could go to that point there maybe, okay? And let's join A to that point, okay? And also B to that point. And you notice, right, visually, you could see that is a right angle, okay? Because those lines are extended from A and B, which are the end points of this diameter, okay? And that's true for any other point here in this semicircle. You can take that point there, go from A to that point, okay? From B, and you can see just about you have a right angle there, okay? So any angle in a semicircle is a right angle, okay? Next theorem, okay, is this one here. Angles in the same segment are equal, okay? So you could see the angle here. Visually they look the same, don't they? And they are the same, okay? So these angles are formed from these 2 points A, B, okay? So you can see the lines subtending from A and from B, okay? So you can see that angle there is formed by this line coming from A and from B. And the same then can be said of angle D coming from A and B. Same for angle E. These angles are identical. Okay, next one. This one here, okay? We're using letters to show what's going on. Okay, but again, it's a really simple idea. Okay, when you have angle subtended from these 2 points A, B, okay, the angle at the center, the angle that's formed at the center, right, called it 2x, whereas the angle formed at the edge of the circle, at the circumference, is x. In other words, when you have an angle formed from A and B, the angle at the center is double that of the angle at the circumference there. That's always true. Okay, so if that angle there was say 30 degrees, that's going to be 60. Okay, that's always true, right? Or if that's going to be 80 degrees, that would be, sorry, if this would be 80 degrees at the center, that would be 40 degrees, if that makes sense, yeah? So the angle at the center is double the angle at the circumference. Okay, then we've got another theorem, okay? And here we've got what is known as a cyclic quadrilateral, okay? Now you know what a quadrilateral is. Quadrilateral simply has got 4 sides, right? 4 sides, and it's called cyclic because each of the corners are touching the circle, if you notice there, right? Each of the corners are touching the circumference of the circle. Okay, so you've got A, B, C, D. Now in this case here, the opposite angles add up to 180. Okay, so angle B, angle D, add up to 180, and the same can be said then angle A, angle C, those two will also add up to 180. And then the last sort of theorem here, a couple of things going on here. A tangent meets a radius at 90 degrees, okay? Now of course we know this is the radius of our circle, right? And we've got another radius here. The tangent, of course, tangent touches the circle. If you remember what a tangent is, a tangent is simply a line. Tangent is a line. It doesn't go through the circle, it just touches it. So you can see it touches there at A. Okay, and what's true is, right, a tangent would always meet a radius at 90 degrees. So where you've got a tangent and a radius meeting there, that would always be 90 degrees. Okay. The other idea that gets across here as well is when we have two tangents, okay, the tangent there, of course, because it touches the circle at A, you've got another tangent here, it touches the circle at B. When you've got two tangents, okay, in this case, they meet at a point here, okay, then this length going from A to C will be equal that length B to C, right? So we could even put here marks to show that they're equal. Okay, they look equal, don't they? Right? And what's also significant about this, and we see now in some questions, is, right, of course, because we know this side is the same as that side, I can maybe put 2 marks there to show that these two are the same, right? We've got ourselves that side is the same as that side, this is the same as this. And watch what happens when I join O to C, okay? Notice it splits into 2 triangles, okay? 2 triangles, and in this case here, the 2 triangles are congruent, okay? The 2 triangles are identical because all the sides are the same, aren't they? That is the same as that, this is the same as this, and this side here obviously belongs to both. So they're identical, alright? Which means that this angle is the same as this angle, and then this angle here is the same as this angle. Okay, so that's about as complicated as it gets. Let's just look at some questions. So circle theorems then. Let's look at number 1 here, right? It says find the size of the angle marked X, alright? So if we think back to our theorems, right, that we looked at, and of course this one belongs to the first one, doesn't it? Okay, the one that I sort of drew on here, alright? Here we've got angle in a semicircle is a right angle, yeah? So if you notice here, okay, we're focusing on this half of the circle, aren't we? This half of the circle here, we ignore this half, okay? We've got a diameter here, which means that the angle then formed by these 2 lines is always a right angle, okay? Angle in a semicircle is a right angle. So if I know that to be 90, that's 28, I can work out X, can't I? Because I've got myself a triangle, right? So obviously angles in a triangle add up to 180, right? So I add what I know that's 90, I know that's 28, 90 or 28 is 118, okay? And to get X then, all I've got to do is take what I know away from 180, so take the 118 away and I get 62, okay, 62 degrees. Right, so if we look at number 2, right, number 2, and this is going to use the second theorem that we looked at, okay, here. In this case here, it's asking us for us to find angle X, alright, and what I've noticed here, of course, is this idea here, right, this idea of angles in the same segment are equal. Notice here that these angles here, okay, these angles here are from these 2 lines coming from A and B, angle there from the 2 lines coming from A and B, and so on. And the same can be said here. If you focus on that line and that line there, forming that angle of 25, that line and this line, they both come from this point, these 2 points here. And the same can be said about this angle here. That line comes from that point, this line comes from this point. So angles in the same segment are equal. That's got to be 25. Alright? And then once you've worked that out, we can use our idea of triangles again. Yeah? An idea of triangles adds up to 180. So we've got 120 and 25. It's 145. I'm adding what I know. And then I see what's left then. Because it's triangle, see what's left from 180 to get X.
Morgan Payne, Kieran Curtis and Brooklyn Williams are in the building. Please can you come to reception now?
Okay, so we end up having 180 take away 125 is 55 degrees. Right. Question 3. read through all this here, and then it says find angle ACD, right? ACD. Now, ACD, so this is the angle here, all right? Now, same sort of idea again, right? Same idea again, angles in the same segment, all right? This angle here is 32, right? It's exactly the same as that there, okay? Because if you notice, this angle, right, is formed by those two lines, and those two lines come from B and C, right? And the same can be said of this angle here. Those two lines come from B and C. So they're both 32, all right? So now I know those two, add them up, okay? They come to 166, so then, because I've got a triangle, that's got to be 14, isn't it? Okay, so ACD will equal 180, take away 166, 14 degrees. Okay, question 4, right? Angle A and B we're asked to find. So in this case, right, we're going to use this theorem here, right? Remember I said about opposite angles in a cyclic quadrilateral add up to 180 degrees. Let me just check here. If you ignore B for a minute, ignore those there, you notice you've got a cyclic quadrilateral of 4 sides. Opposite angles in that cyclic quadrilateral add up to 180. So if that's 125, you can work out A by taking 125 away from 180, so you get 55 degrees. Now what's useful with these questions, and I always encourage this, draw on the diagram, write in any information you know, write it in, so we know that's 55. Okay, so then, to get angle B, we're going to use a different theorem. Can you remember the other theorem we could use? We've got an angle at the circumference here, an angle at the centre. So remember this theorem, angle at the centre is double the angle at the circumference, right? So the angle at the circumference is 55, that one's just going to be double it, okay? So B will be 2 lots of 55, which is 110, okay? Alright, this one now, similar type question, a little bit more challenging towards the end. Asking for angle ABC. ABC. So this one here. Alright. Of course, the same idea again, yeah? Cyclic quadrilateral, opposite angles will add up to 180. So to get ABC, do 180, take away 109, which comes to be 71 degrees. Okay? Sides then of ACO. Right, now let's look at what ACO is. Alright. ACO, well, ACO is this little angle here, isn't it? Okay, that's right, isn't it? Because it's ACO, so it's this angle formed by the lines AC and CO. Okay, so we need to work that out. Now let's write in obviously 71 there, because I've worked that out. Let's think about what else we can work out now. Okay. Remember now, there's this other theorem, the theorem we looked at last question. Angle at the centre is double, isn't it? The angle at the double that angle. So if you double that, you get 142 here. That's actually going to really help you now to get ACO. Because you notice here you've got a triangle. Okay. And if you think about what's left now from there, triangle, this triangle here, AOC, the angles add up to 180, don't they? So if we take 142 away, you end up with 38, okay? But what's clever about this triangle, of course, if you think about it, those two angles there, I mean, they look the same, don't they? And they actually are the same, because if you think about it, that's a radius, and that's a radius, yeah? So it's a nice isosceles triangle, because you've got 2 radiuses, and the radius, that radius there is the same as this radius. So 2 sides the same, so it's isosceles, okay? So that means you just split 38 by 2, okay? And you'll get then this angle here for ACO which is 19 degrees.